Hello, Algebra 1 class. This lesson about fitting lines to data is a continuation of lesson 4 where we were creating linear models. We're really creating linear models here too. Take a look at the learning targets. We will be using Desmos as our technology to find the line of best fit. Go ahead and try this warm-up. Pause it here, and then I will show you the answers. Okay, your answers are as follows. I think in question 1, it's pretty clear that it's the solid. You can see the data is being decreasing as you go to the right. In number 2, it's a little harder to determine. I would just say the solid line is a little bit lower with a smaller y-intercept. And you can see that the dotted line is almost above the data. Okay, in 3, you can see the slope of the solid line is a lot steeper than that of the dotted line. Notice that the solid line kind of starts below the data and then above the data. You really want to turn the line so it's kind of hitting as many points as possible. And in number 4, this one I would say again it's really close, but the dotted line is better. It doesn't have to hit as many points, but it has to go through or be near more of the points. Okay, for this activity, you're going to need to look at 7 cards that are labeled A through H. You should do this in the notes file that I gave you. And what you can do is you can pause this video here, look over the 7 cards in the notes file, and then answer the questions for A, B, and C here. And then for each card, you want to write one sentence that describes how Y changes as X increases. Now, we don't know what the data variables represent, so you can just say something like Y decreases as X increases, or Y increases as X increases. Oh, noticed a typo. Yuck. Oh well. All right, so pause it here and look over the cards and answer the questions. Okay, so I am now going to go through the 7 cards, answering really kind of each card question first, the one down here, and then at the very end, the third slide in, you'll see my answers for the ordering of the cards. So let's go. All right, so for A, it's a good linear model, and B, also a good linear model. C, good linear model. There's 2 outliers though. I guess I should go back. A, as X increases, Y increases. B, as X increases, Y decreases. C, as X increases, Y increases. And D is not a good linear model. Note, this is actually a trigonometric model. It's one of the functions you'll learn later when you get to pre-calculus, but it's not linear in that most of the data does not form a line. All right, for card E, good linear model. As X increases, Y decreases. F, good linear model. As X increases, Y increases. And lastly, G is not a good linear model. The data is not forming a line. This is something called a quadratic model or parabolic model, and you'll learn about that in Algebra 2. On the next slide, you're going to see more of the same information plus the data sorts. Okay, so for the data sorts, the first question was best to worst for representing with a linear model. So this is how tight the data fit. It went B, A, F, C, E. All right, for question B, this is about least to greatest slope, and it goes E, B, C, A, F. They are taking the decreasing lines, E and B, and kind of the smallest slope or most negative slope first, then the flatter negative or decreasing line in B. And then C, A, and F, they're going from flat increasing or less steep increasing to steepest increasing, which is F. This is, since we're not calculating the numbers, kind of, your best estimate based upon what you see. And then for C, it is the least to greatest vertical intercept or y-intercept of the data. And you can just kind of extend your lines and see where they cross the y-axis. Smallest to largest number goes A, C, F, B, E. For question 2, you can see the answers that I already went over with a little more information. So feel free to pause it here and make sure you understand why the answers are what they are. For this activity, activity 5.3, fitting lines with technology, we're given a data table. The weight of ice cream sold at a small store in pounds, that's your X variable. That represents the weight of ice cream in pounds sold. And then this is the average temperature outside in degrees Celsius. And that's recorded in the table. So for each of these ordered pairs represents a day. And so on this day, 20 pounds of ice cream were sold, and it was 6 degrees Celsius out. So the first thing you want to do is open your Desmos, and you're going to enter this data in. So the lesson, maybe it was 2-3 days ago, where I had you go through a tutorial on Desmos, learning how to enter a table of data and doing a line of best fit will come in handy now. Feel free to go back to that lesson and practice again. I'll try to walk you through it a little bit here, but you're going to have to make sure you can do that. So what you're going to do is enter Desmos Graphing. You're going to hit the plus sign and enter a table. In your X, it's actually going to go down as opposed to across. In your X, you're going to enter these numbers right in a row. And in your Y, you're going to enter these numbers. It'll be going down in the second column. And then when you enter these ordered pairs, it will graph, and you can pinch it in or out, and it will create a scale for you. It's really nice. But then you're going to use technology to compute the line of best fit. So what you do here is you hit the plus sign again, choose the F of X. It looks like this. Hold on a second. F of X button. And you're going to enter Y1 tilde to get to that little symbol there. It's not an equal sign. It's what we call a tilde. You're going to want to go to the keyboard, and then I think you have to choose the ABC keyboard. Like there's a little button to switch the keypads, and then enter that. And then you're going to enter MX1 plus B. And what it will do is we'll create the best line of fit that it can. It's going to use something called linear regression and give you an equation. All right. Once you've done that, I want you to answer the questions 3 and 4. So why don't you pause the video now, and then when you unpause, you can see the answers. Okay, so now you can see I've entered some data here. The first is this equation. This is the line of best fit equation I got from using Desmos. You should match this right on if you use the same data as I. And then we have to answer this question. What's the slope and y-intercept? Just taking it right from the equation. So the question is, what do these mean? The slope means for each additional ice cream pound sold, that's how hotter it was, how many degrees Celsius hotter it was. So almost a degree Celsius more. And then the y-intercept says when there is no ice cream sold, no pounds of ice cream sold, then the temperature is negative 9.44 degrees, which may or may not be true, but that's what the model tells us. And then it says predict the y value when x is 10. So all you're doing is plugging in 10 for x here. So you do 0.78 times 10, which is 7.8, subtract the 9.44, and you end up with negative 1.64 degrees Celsius. Remember, y, the output, is the temperature in degrees Celsius. So, is this a good estimate? Well, it works according to a model, and if we graph it, it looks right. But, the question would be, when it gets to a negative temperature, is the model still good? And that's, something that sometimes a linear model is only good for a certain portion of the data points, if you will, what we call the domain of the function. But for our answer, this is what we have. Okay. Okay. On this, you just get another opportunity to see how you do using the technology to create scatter plots and find a line of best fit and interpret the information. I would pause it here, take your time, work through this, writing down your answers, and then when you unpause it, you will see the answers and I will briefly explain them. Okay, here are the answers. You should be pretty right on with me if you entered the data correctly and did the entry of the equation. So this isn't an estimate. This is the line of best fit as calculated by the technology. The slope is 1.57. And what that means is for every additional mile, the price costs $1.57 more. So this is ride services around the city. So every additional mile, it costs $1.57 more. And then the Y-intercept is 7.6 or $7.60. And that means, that's the cost of getting in the cab or the Uber without actually driving any miles. And then 3, use the line of best fit, this equation, to estimate the cost of a 3.6 mile trip. So here, if I plug in 3.6, because X is miles, and do 1.57 times 3.6, add 7.6, you'll get $13.25. Is this a good estimate? You can look at it on your graph and see how good it looks. Also, you can see here for a 3.5 mile trip, it's 13.25. So it's pretty good with our actual data too. All right, on the next slide are 2 more questions. Once you get there, pause it, read them over, answer them, and then unpause it. Okay, so both of these questions ask you to keep Desmos open, and in number 4, you have to add in an 11th trip. So you add in the ordered pair, that's 3.6 comma 4. When you get your new model, you can see now it's y equals 1.27x plus the y-intercept, and that slope has decreased from the slope of before, which was 1.57. It's not surprising that it decreased because $4 for a 3.6 mile trip is a pretty low data point. Okay, in question 5, you're adding a 12th point. So this point is the ordered pair 4.1 miles for $24.75. So how do you think the slope of the equation of this line of best fit will change? It will increase greatly because $24.75 is really expensive for 4.1 miles. Time for the cool down. Try these problems on your own. So we have a problem on this page and then the next slide. So pause it here. Okay, so I hope you all chose C. You can see that this one is just scattered all over the place, and it's really hard to see if the data is increasing like this or decreasing like this. So it's just not organized data at all. And then in B, you can see that it kind of starts out like a line, but then it shoots up. So this would be more of an exponential model or another kind of model. And then C, of course, you can see a nice linear model going on there. Okay, go ahead and pause it here, read through it, and make your best estimate. Feel free to actually put this in Desmos to come up with the right answer. Okay, the right answer is C on this one as well. The first thing you might notice is that it's an increasing function. Let me just try to draw in a line of best fit here. So you can see if I'm drawing in a line of best fit, it's definitely going up. That means our slope has to be positive, and that removes the first one. The next three all have positive slopes. So is it a steeper slope closer to 1, or is it a flatter slope like in C? And this, it's kind of hard to tell from the graph. You could take 2 points that are really close to the line. So maybe the point here at like 528, and maybe the point here at 175. And you could calculate the slope. You could take y, 74.45, minus 25.64, and divide it by 528, divided by, or subtract 175, and you'll get closer to 0.13. The other thing is if you do use Desmos, you will get this. And then the last thing is the y-intercept. You can't just say where did it cross the y-axis here, because this starts at 100. So it's a little off in that the scale really, if that's 100, it's about here is the real y-axis. So by the time it gets down there, you can see it's going below 0. That's why these three are negative. So the question is how far negative? And it's really not far below 0, so the answer is 0.19. And that's why it's C. All right, that's for the lesson. Go ahead and try your homework assignment.